Hi, class. This is just a short video and kind of a practice video also. I'm going to be putting more up on Canvas, but this is just to go over the Unit 3 activity, Chapter 6. It was offered as an extra credit. Some did, some took advantage of it, some people didn't. But if you need to look on Canvas, I put the answers to the activity. And then I also want to just quickly go over these and explain how you get those answers. And it's important whether you did the activity or not, is that you use this to study for the next exam, because these questions will be on. This makes up about half of the Unit 3 exam. Now, number one, which is a well-defined set? Well-defined means that everybody would pretty much agree on what elements are in that set. Now, A says the top 5 greatest football players. That's kind of an opinion. Uh, People would argue who was the greatest football. Best vacation sites, again, that's kind of an opinion. Small dogs, what do we mean by small? That's kind of iffy. But D, the states that border Ohio, that's exactly known. We know all the states that border Ohio. There's no opinion on that. All right, so number two, which is not a common method to indicate a set. Now, description, that is a common method. So you describe in words what is in the set. Roster form means you list all of the elements out that are in the set. Grouping form, not a common method, so that's why we put C up here. Set builder notation is a mathematical way. It's kind of a shortcut method for writing large sets. Like the set of all real numbers, we can write it with a very simple set of notation and so on. So 2 is C. Number 3, the two sets A, B, C, and D, and A, B, C, and D over here, they're exactly the same, so they are referred to as being equal. And number 4, these two sets have 1, 2, 3, 4, 5 elements. 1, 2, 3, 4, 5 elements. Then that means they are equivalent. So sets that are equivalent have the same number of elements. And number 5, given that A is 1, 2, 3, 4, 5, so here we have 5 elements in this set, and which is a subset. So that means a set that has these in it, or some of these. So let's look. 4, 5, and 6. No, that's not there. How about 1? So this set is mainly or totally made up of elements from up here. So we got 1. There's a 1 up here. That's not it. So B. What is a proper subset of A? Let's take a look at that. So 1, 2, 3, 4, 5. So here's 1, 2, 3, 4, 5. Is that a proper subset? No. It's a subset of A, but it's not a proper, which means it has to have at least one less elements. It has to have one less number of elements than the original set. So this one, 1, 2, 3, does have less elements than this one. And these all came from this one. So this would be a proper subset B. Now this one, A, B, C, D, E, has 5 elements. It's equivalent to this one, but it's not a proper subset. So let's get on to 7. How many possible subsets of A are there given that A is this? So this has 6 elements. The formula is 2 raised to the number of elements power. So 2 to the 6th, that would give me 2, 4, 8, 16, 32, 64 elements. So that's D. So there would be 64 subsets of this set right here. 64 possible subsets. All right, the two sets A equal 1, 2, 3, 4, and A, B, C. These would be considered disjoint because they don't share anything and nothing. So they're totally separate. Number 9, given a universal set, these elements right here, and a subset called A. Okay, ABC. So these three came from this up here. We're saying this is a subset of this universal set here. Now, what's the complement of this set here? Okay, so ABC, ABC here, and then everything else is in the complement set. So D, E, F, and G, that set would make up the complement. What we're not, or what's not in A, okay, from the universal set. These are the elements that are not in A, set A, right? So C, D, E, F, G right there would be C. Let's see, we got A, B, C, and then D, E, F, G, that would be A. Given two sets, okay, these two sets here that are given, we want to find the intersection of these two sets. The intersection means the ones that are in both. So let's look at what we got here. We have a 1, 2, 3, 5, 6, and over here we have 5, 6, 7, 8. So there's a 5 in both of these sets, and there's a 6 in both of these sets. So 5 and 6 make up, right? That's this right here. 5 and 6 make up the intersection of those two. So it's A. Given the two sets, 1, 2, 3, and 5, 6, 7, 8. The union of A is when we take all of this stuff and throw it together. So 1, 2, 3, 5, 6, 7, and 8 would be this one right here, or C. Okay. Now this example was about blood types, and we were looking at a visual approach to overlapping sets and possibly maybe complements or things that don't overlap. And so this is a Venn diagram of blood types. And let's take a look at this. So how many people have blood type A negative? So you have A, B, or an Rh factor in your blood, or maybe none of them. And let's see, so this circle right here is the A circle. All of these things have the A antigen, and all of these have the B antigen, and all of these have the Rh factor, okay? And they overlap, so the negative means no Rh factor, so A only. So this right here, there would be 21 right in here. Okay, so that's B, so only A. So how many people have B positive? All right, so all of these people have B. The ones that have B positive means they have B and the Rh factor, so that's right in here. These overlap, so 12 would be the next one. How many people are AB positive? That means they have A and B and Rh, which puts this area right in here, is in all three circles. So 4 for this one. How many people have O negative? So O negative means none of these three. So you're out here, 25 people have none of this stuff, A, B, or Rh. Okay. How many people have C negative? Well, that was a trick question. None of them. Nobody has C negative blood type. How many people have A positive? Okay, that's A with Rh factor. So that's right here, 7. How many people have B negative? Which means B and no Rh. No Rh, no A. This would be just this right here. B negative would be right here. And that's about it for that. So let's go on. And we're going to look at the table here. So we've looked at frequency tables before, and this was given number of credit cards somebody had. So they asked people, how many credit cards they had. And some people said none, some people said 1, some people said 2, and 3, and 4, and so on. 7 people, right? Frequency is counts. 7 people said they didn't have any credit cards. 33 said they had 1 credit card on them. 18 people said they had 2, and so on. So they asked a total of, if you add these all up, you get 83. So 83 people responded to how many credit cards they had on them. Now, the relative frequency is you simply take this number divided by 83, which is a total. 7 divided by 83, 0.084. 33 divided by 83, 0.39, and so on. So you divide each one of these numbers by 83, which is again the total of all these added up, to get the percentages or probabilities. Cumulative counts start here. First one is 7, and if I add these two together, I get 40. If I add these 3 numbers together, I get 58, and so on. If I add these ones all up to here, come over here, I get 70, add in 8 more, and 5, and we get the total, 83. Okay. All right, let's get down to these questions. The person does not have any credit cards on them. Well, there's 0. It's about a 0.084 chance, so that's where this came from. The person has 3 credit cards on them. All right, 3.145, so that's that. If the person has less than 3 credit cards, less than 3 means 0, 1, or 2. So if you add up these frequencies, these 3 right here, and divide by 83, right, then you would get that number right there, 0.699. So you got to add, or you could just add these 3 up to get that. The person has at least 2, means 2 or more. So that's this one, this one, this one, and this one. Add them all up, and you'll get this number right here. Person has 4 or more credit cards on them. Here's 4 and 5. 4 or more means 4 and 5. So add these 2 together, and you get that. And the last one, person has between 1 and 3. Inclusive means I'll take 1, 2, and 3, add these up, and I will get that number right there. So that's it for our Unit 3 activity video. Okay. Remember, you need to study that for the Unit 3 exam.